endo and exothermic reactions. In an exothermic reaction, the reactants have more energy than the product. Because energy is always conserved, in an exothermic reaction, heat will be given out, so we can measure this using a thermometer. Whereas in an endothermic reaction, heat will be taken in. So which is it for the reaction between hydrogen and oxygen? First, we need to know the bonds. Hydrogen and oxygen always come in pairs, and the product is water. Because we have two oxygen, this means we also need two water molecules because matter is conserved. This then means we also need two lots of two hydrogen. Oxygen creates a double bond, hydrogen is single, and each water molecule, one oxygen binds to two hydrogen. We need heat to start this reaction. A hydrogen to hydrogen bond contains 436 kilojoules per mole. And we have two of these, which leaves us with 872 kilojoules of energy. A double oxygen bond has 498 kilojoules. The sum of this is 1370, meaning this is how much energy we would need to break these bonds. The amount of energy needed to make these bonds would be minus 1370. An oxygen to hydrogen bond is 464 kilojoules of energy, and we would need 4 of these. This is 1856 kilojoules of energy per mole. But these bonds are being made, so it would actually be minus 1856. The sum of these two totals is minus 486, which means we need to put in minus 486 kilojoules of energy into the reaction, which is the same as getting out 486 kilojoules. So for every mole, 486 kilojoules of energy is going into the air, making the reaction exothermic. So we put energy into breaking the bonds, but when making the bonds, we got energy out. Things with bonds have less energy, which is why there are more intermolecular bonds in solids than in gas. In an exothermic reaction, the product being made will fall below the energy of the reactants. The rise in our graph shows bonds being broken. The fall in energy is where bonds are being made. This energy being given out in an exothermic reaction explains why things combust. The opposite is true between the reaction between nitrogen and oxygen. The bonds between the reactants contain less energy than the bonds between the products. So on a graph, the energy of the product would not fall below the original energy of the reactants. This is good for the reaction between nitrogen and oxygen, because otherwise our atmosphere would have exploded years ago. The end.